Hello everyone, welcome to an algebra tutorial video learning about geometric sequences. In this video, we're going to learn how to write a formula to represent all these patterns of geometric sequences that we've been working with. So geometric sequence is simply just a number pattern in which we multiply by the same number over and over again to get the next term in the sequence. So a formula, I'm going to write the formula, then we're going to put out an example and show how to use and interpret the formula. So in a sequence, I can write a formula for a geometric sequence. Any term, so that's a with a little n, a sub n, just means any term is equal to the first term, that's a sub 1, that just means the first term of the sequence, times r. R is our common ratio. That's what we're multiplying over and over again. R to the n minus 1 power. And if you've seen the previous video, you know that repeated multiplication, because that's what the sequence is we're multiplying by the same number and over again, we use exponents to represent what we're multiplying by over and over again. Makes it much easier to write things up. So there we go. That's my formula for a geometric sequence. Now let's actually look at an example. So we're going to play around with this sequence pattern right here. The first number is going to be 80. Then we've got 48, 28.8, and 17.28. And it keeps going on and on. So there's my geometric sequence. And we're going to translate this and write it in a formula. So to get this, I need to know what the first term is. So that one's pretty easy. I'm starting with 80. So my value, the first term of the sequence, is going to be equal to 80. All right. Now I need to figure out, well, what is R? R is my common ratio, so I've got to play around with consecutive terms and see if I can figure out, well, what is that common ratio? So let's go ahead and do some division. Take consecutive terms. I'm going to do 48 divided by 80. And just for kicks, I'm going to go ahead and do all of them just to make sure that it is a sequence, a geometric sequence. We're going to do 28.8 divided by 48. And then we're going to do 17, we're going to see what that equals. Then we're going to do 17.28 divided by 28.8. All right, so pull out my calculator. 48 divided by 80 is going to be equal to 0.6 or 3/5, depending on how your calculator interprets it. I'm going to use 0.6, I like the decimal. 28.8 divided by 48 is also 0.6. Should write a 0 in front. That makes it a little bit cleaner and easier to read. And if I divide these other two, 17.28 divided by 28.8 is also 0.6. All right, so I'm going to be multiplying by 0.6 repeatedly over and over and over again. That's my common ratio, and that's what we multiply to get the next consecutive terms in the sequence. All right, so how does that translate into a formula now? Well, I put these values in for A1 and R respectively, and I get this formula right here. Any term in the sequence is going to be equal to 80, that's what I'm starting with, times 0.6 or 0.6. I'm going to use a parentheses to make it clear. 0.6. That's what I'm multiplying by over and over again. And I'm going to make it one less in terms of the exponent. So I'm going to take the 0.6 to a power, but it's going to be one less than whatever term I'm going to find. All right, so we've just got a formula written. This is representative of this pattern right here. It's a way to condense and show what's going on. So how does that help me out now? Well, let's actually use this thing. What if I want to find the 34th term? So the 34th term in the sequence, using my formula, is going to be equal to 80. That's a constant value. That's my beginning value. It always stays the same. Times a bunch of 0.6s. That's the pattern, right? Multiply over and over again by 0.6. But how many 0.6s do I multiply by? Well, one less than whatever term we have. So if I'm finding the 34th term, I'm going to have 34 minus 1 means 33 power. Now it's just a calculation. So let's see what all this equals. I need to do the exponent first. So what is 0.6 to the 33rd power? I'm going to do that. 0.6 to the 33rd. Whew, it's a tiny number. I got 4. Use some scientific notation here. 4.7752 times 10 to the negative 8th power. So it makes sense, right? 0.6 times 0.6 times 0.6. It's almost like taking a half of a half of a half of a half 33 times. You're not going to have much left, but I'm going to multiply that by 80 times 80. And my calculator is giving me a really rough estimate. I think it did some rounding on its own here, but it's calling it 0.000004. But there we go. That would be the 34th term in the sequence, which is practically 0, which makes sense, right? But there you go. That's how we use a formula for geometric sequences. And once you have the formula, I can find any term I want. I can find the 34th term. I can find the 8th term, the millionth term, although that might not be very practical in this case, but it helps me find values and understand the pattern and work with this whole geometric sequence pattern.